Review questions, chapters 3 through 5, selected word problems. Problem 86 on page 252. A person is driving a car along a straight road. The graph at the top of the next page shows the distance y in miles that the driver is from home after X hours. Question A. Is the person traveling toward or away from home, and why? At 0 hour, we note that he is 250 miles from home. After 5 hours of driving, he is at 0 miles from home. For question A, therefore, at time 0, the driver is 250 miles from home. After 5 hours, he is 0 miles from home, or is home, which means he drove towards home. For part B, the graph passes through 1, 200 and 3, 100. This means that at 1 hour of driving, the driver is 200 miles from home. After 3 hours of driving, he's 100 miles from home. For part C, use the points 1, 200 and 3, 100 to find M so that we can find the slope-intercept form of the line, and we'll interpret the slope as a rate of change. Slope is the change in the y-axis, which means 200 minus 100 miles, over the change in the x-axis, which is 1 hour minus the 3 hours. This gives us 200 minus 100 is 100 miles, and that took him 1 minus 3 hours, which is negative 2 hours. M is equal to, simplified, negative 50 miles per hour. If we note that at 0, he's 250 miles, that's the y-intercept, which makes b equal to 250. We just have to substitute all our information into y equals mx plus b to get y equals negative 50x plus 250 in slope-intercept form. Part D says use the graph to estimate the distance from home after 2 hours, and check your answer using your equation from part C. So looking at the graph, after 2 hours, we see that the driver is about 150 miles from home. If we let x equal 2 and use our equation in part C, we will get y equals negative 50 times 2 plus 250 is equal to 150. So the answer for parts B, D, and C check out. Problem 70, page 306. The smaller of two angles that sum to 180 degrees is 30 degrees less than the measure of the larger angle. Find each angle. Let's take some clues from this word problem. The first is that two angles sum to 180 degrees. The next is that the smaller angle is 30 degrees less than the larger angle. Let x be the smaller angle and y be the larger angle. In algebraic equation, the first sentence will say that x, the smaller angle, plus the larger angle, y, will be 180 degrees. The second one we can write verbatim in this way. If the smaller angle x is, which is the equal sign, 30 degrees less means it's minus 30 degrees less than, that's the plus sign, of the larger angle, y. Now we have two equations and two unknowns. To use the substitution method, we will let x take the place in the first equation and make it negative 30 degrees plus y, plus the other y is equal to 180 degrees. Combining the y terms, we'll have negative 30 degrees plus 2y is equal to 180 degrees. We'll add the 30 degrees to both sides so that we'll just be left on the left side 2y equals 180 plus 30 degrees, which means 2y is equal to 210. And then finally, y is equal to 105 degrees. That's the larger angle. Let's recall that in the equation, x is equal to negative 30 degrees plus the 105 degrees for y. So we could solve for x, which becomes 75 degrees, the smaller angle. Problem 72 on page 306. A rectangular garden has 88 feet of fencing around it. The garden is 4 feet longer than it is wide. Find the dimensions of the garden. Around the garden means perimeter. And then the garden's length is 4 feet longer than its width. If we let L equal the length of the garden, that is, it's equal to 4 feet longer than the width. For the garden's perimeter, we have 88, and we know that the perimeter is twice the length plus twice the width. Now we have two equations and two unknowns. The substitution methods allows us to place 4 feet plus W into the first equation, which will make 2 times quantity 4 feet plus W plus 2W equals 88 feet. We combine like terms. 2W plus 2W is equal to 4W. We'll subtract 8 feet from both sides to get 4W equals 80 feet. We know that the width now is 20. And if the length is 4 more than that, then the length is 24. Problem 73 on page 307. 10 rooms are rented at rates of $80 and $120 per night. The total collected for the 10 rooms is $920. Write a system of linear equations whose solution gives the number of each type of room rented. Be sure to state what each variable represents. Let's begin with x equals the number of $80 rooms, and then we'll let y equal the number of $120 rooms. The total number of rooms is 10, which means that x plus y, the total number of $80 rooms and the total number of $120 rooms, will equal to 10. The total collected is 920, which means that if we have x number of 80 rooms at $80 and y number of rooms at $120, we sum that together and our total will be 920. We can use the elimination method to solve the system of equations. If we let x plus y equal 10, the first equation, multiply that by negative 80 across, we will get negative 80x minus 80y is equal to negative 800. We'll add the second equation of the number of dollars that collected at 80x plus 120y equals 920. The 80x plus 80x, it will equal 0x. And then 120y minus 80y is 40y, and 920 minus 800 is 120. We'll divide 40 to both sides of the equation to get y equals 3, the number of 120 rooms. We know that the number of total rooms is 10, which means that the number of $80 rooms will be 7. Problem 76 on page 307. A riverboat travels 140 miles downstream in 10 hours, and the return trip takes 14 hours. What's the speed of the current? Let's imagine going down the river. If there is current, our speed will be faster going down, and going up will be a little slower. So going downstream is with the current, going upstream is against the current. The distance going up or down is 140 miles. The rate going down is, we did 140 miles in 10 hours, or 14 miles an hour. The rate going up is 140 miles, and that took us 14 hours, so we went 10 miles an hour going upstream. Let x be the speed of the boat. It's still water with no current. Let y be the speed of the current. We know that going downstream, the boat rate is with the current, so that our rate going down is our boat plus the current is 14 miles an hour. Going upstream, the boat rate is against the current, so we're slowed down a bit. So our rate going up means that our boat minus the current speed is equal to 10 miles an hour. Using the elimination method, we add both equations to get x plus x is 2x, y minus y is 0y, 14 plus 10 is 24 miles an hour. We can isolate x by dividing 2 to both sides of the equation to get x equals 12 miles an hour. That's the boat's speed, but we're after the speed of the current. If that's the boat speed, we know from either equation that 12, which is the boat speed, plus y is 14 miles an hour, or 12 minus y is equal to 10 miles an hour, that the solution is that the current speed is 2 miles an hour.